Hello, hello, it's Mrs. Trombley. We are finally ready for the last portion of the first section. Yes, I told you there was a lot to learn in this section. I was not joking, because I never joke. I'm sure you already know that about me. Okay, so the reason that we've been changing back and forth from fractions to decimals to fractions is so that we can get to this point where we're able to compare rational numbers. We've already done some background with this when we started in chapter 1 and we're talking about absolute values and placing things on the number line and ordering values from least to greatest. So you have some background, but now fractions and decimals are going to be involved. So it'll be a little bit more challenging. Hopefully this will help. So these words right here I actually copied and pasted from your lesson in 1.1. A number line can be used to compare and order numbers. It's a great and useful tool. Numbers to the left are always going to be less than the numbers to the right. Numbers to the right are always going to be greater than the numbers to the left. So basically, if we can place those numbers on a number line, we know that the one that's all the way to the left will be less. Less and left start with the same letter, so that's a nice way to connect it. All right, anywho, I want you to try it. I give you two values to start, and I give us a number line, and you don't have to have some pretty typed little number line. If you don't have a number line on your sheet, you could quite easily make one, I'm sure. Right? So you don't need that, or don't say, there's not a number line though. You can draw your own, which is what I'll have you do in a little bit. So I have negative 1.2 and negative 1.25. They seem like they'll probably be pretty close, right? Because in first place, I have a negative 1 and another negative 1. So same digit there. I know they're not equal because they're not exactly the same there, right? So let's place negative 1.2 on the number line. Here's negative 1. Right? Now, if we're counting on the number line, if I was going in the positive direction, this is 0, 0 to 1, and we're heading in this direction, that would make halfway through 0.5, right? Now, when we're heading this direction, I'm still counting, I'm just counting kind of in the opposite direction. So here, the digits are getting greater as I move to the right. Here, the digits will get greater as I move to the left. So that would mean that if I'm heading from 0 to negative 1, halfway between 0 and negative 1 would be negative 0.5. And there's negative 1. And that would make this negative 1.5 and then negative 2. And then negative 2.5 and negative 3. And I just chose 0.5 because I think that's the easiest one to start with, right? And I'll just finish it off because I have to. I can't just leave that one undone. So let's use that to kind of help us. First off, if I said this the real way, it would be negative 1 and 5/10, right? Tenths is what it's out of. So that would mean that there are actually 10 slots, if I'm counting by tenths, between negative 1 and negative 2. So if you have negative 1 and 2/10, that would mean it's between negative 1 and negative 1.5. And if this is 5/10, let's make these tenths. So here would be negative 1.1, negative 1.2, negative 1.3, negative 1.4, negative 1.5, negative 1.6, negative 1.7, negative 1.8, negative 1.9, and negative 2. And I missed my calling as an auctioneer. So again, the reason that I made these 10 marks to get there, or 10 sections I should say, is because this was, I started off and I'm putting it into tenths. So that means I want 10 spaces. So negative 1.2, here's negative 1, and again, when I'm going to the left, I'm counting from the right to the left, this would be negative 1.1, this would be negative 1.2 right here. So here is negative 1.2. If I was going to place negative 1.25 on here, if this is negative 1.2 and here's negative 1.5, wouldn't negative 1.3 be right here? Yeah. Negative 1.3 would be right here. That means if this is negative 1.2 and this is negative 1.3, negative 1.25 would be between those. So halfway between would be negative 1.25. Which one of those is farther left? I know they're close, but do you see how negative 1.25 is farther left than negative 1.2? That means, because it's farther left, that it's less. So this is going to point at the negative 1.25 saying, haha, you are less than me. Yeah, pretty easy, right? I know. It's tough. But again, we're using a lot of prior background knowledge, and I think once it's activated, you will be fine. Alright, next I have negative 2 and 1/4 and negative 2 and 3/8. Now, some of you look at this and you think, ooh, fourths and eighths, those are easy to convert. If you have negative 2 and 1/4, that just means I have 4 sections between negative 2 and negative 3. And to compare this, I would need to make 8 sections instead. And you can go ahead and divide that up. Some of you are like, what are you talking about? If you look at me and you're like, what are you talking about? Then I would probably do some conversions here and change these to decimals, because then we can just use probably our tenths place to help us. So if you have negative 2 and 1/4, that 1/4 is a benchmark fraction. We've dealt with that before. We know that 1/4 is equivalent to 0.25. So this means negative 2.25. With a negative 2 and 3/8, 3/8, maybe you don't have that one memorized. If you didn't, I know this is negative 2, and to change that 3/8 into a decimal, and again, we're doing that so that we can order this on a number line a little bit easier, and if you already know how to place 1/4 and 3/8 on that number line, then you're probably already done with this one. So 3/8 means I'm going to take 3 divided by 8. I know that 8 doesn't go into 3, so I put that decimal point afterwards. 8 goes into 30 though. 8 times 3 is 24. And I still am not done, I have a remainder. And 8 goes into 60. Well, 8 times 7 is 56. And 8 goes into 45 times. And finally, we have a remainder of 0. So this one would be negative 2 and 375 thousandths. Yep. So in terms of what's what, negative 2.25, well, here's negative 2, and then if we are just going to count by tenths, 1, 2, 3, 4, 1, 2, 3, 4, I've got my 10 spaces in between negative 2 and negative 3. Negative 2.25, here's negative 2.1, here's negative 2.2, here's negative 2.3. Negative 2.25 is going to be halfway between negative 2.2 and negative 2.3. If you have negative 2.375, here is negative 2.3, here's negative 2.4, negative 2.375 is going to be just a little below that. So, negative 2.375 is further left, that means it's less. So, it's going to point at that again and say, haha, I am greater than you. I know, it's very mean, so sad. Alright, next I have a decimal and a fraction that we're comparing. It's negative 3.3 and negative 3 4/5. It would really be helpful, I think, if they were both decimals. This one's kind of nice. It's already set for us. And negative 3.3, here's negative 3, here's negative 3.5. 2, 3, 4. Negative 3.3 would be right here. 3 tallies away from the negative 3, heading to the left. 4/5, maybe that's one that you already know as a benchmark, right? If not, this means 4 divided by 5. So I can take 4 and divide it by 5. That means 4 is on the inside. And 5 doesn't go into 4, so I'm going to add that decimal point. 5 goes into 40 though, 8 times, and it comes out even Steven. So this is negative 3.8. So negative 3.8, here's 3.3, 4, 5, 6, 7, 8 would be right here. Negative 3.8 is further left. That means that it's less. So all 3 of these point in the same way. This is saying, haha, I'm greater than you. Maybe you're noticing that when you're comparing two negatives, it's kind of opposite land of the positives. And in positive, if those were both positive, 3.3 is less than 3.8, right? Easy comparison. But when you're dealing with negatives, the lower the digits, the higher the value, right? Because in terms of how far away it is from 0, 3.3 is closer to 0 than 3.8. Negative 3.3 is closer to 0 than negative 3.8 would be. So that means its value is greater. We'll talk lots about this in class, I'm sure. Okay, so now we're going to take the 2 digits and we're going to apply it to a little number sequence. So we can use a number line to help us order a bunch of values from least to greatest. Doesn't that sound like fun? All we have to do is place the values on a number line and write the values from left to right. Now I'm not going to be grading you on this number line. It doesn't have to be perfect. You just kind of have to roundabout put the numbers where they would go so you know which ones are farthest to the left. Once you have them written there just like before, you can copy down those values from left to right and we'll be good to go. Alright, so in looking at these, we've kind of been seeing that it's a lot easier to put these on a number line when they're in decimal form. So what I would do is I would change any of these that aren't decimals into decimals before you even start. So this is good, this is good, this negative 1/3 is not. 1/3 is one of those benchmark fractions that we probably know. It's negative 0.3 with the bar. It needs the bar to show that it continues because it's not the same as 3/10. Does 3/10 simplify to 1/3? No, so they are different. If you didn't know that as a benchmark fraction, then you're taking 1 divided by 3. And all day long, you'll keep getting 3's. So, same thing. Alright, this 5/10 is good, and negative 5/3, we need to change that. So in negative 5/3, I know it's negative. This means 5 divided by 3. So I'm going to actually get a whole number amount in here. It's nice. 3 goes into 5 once. There's 2 left over. Drop down to 0. 3 goes into 20. Let's see. 3 times 6 is 18. Subtract, we get that 2 again. Bring down a 0. 3 times 6 is 18. So that 6 is going to keep on happening. That means it's negative 1.6 repeating. Once we have them all in decimal form, now I'm going to make a little number line. Let's zoom out so you can see it too. And in looking at these values, I kind of have to pick. I don't want to make an entire giant number line of numbers I don't need. But in looking at this, it looks like in terms of positive values, my highest positive value is this 1.25. So I probably want to end here a little bit more than 1. So let's say 2. And in terms of what would be farthest to the left here, let's see. With my negative values, that is a 0, 0, 0. I see a negative 1.6, so I'm going to want to go a little bit more than negative 1, so let's go negative 2. I guess a little bit less. And here would be my 0. So that's kind of how you would choose those values. Again, we'll do some more practice in class, but that's all I really need to see with my number line. Okay, so let's place each one on here. First off, I have negative 0.5. So this is negative. I'm going to start at 0. And negative 0.5 means that I'm between 0 and 1, or 0 and negative 1, halfway. So this is where negative 0.5 would be. Okay? Now I have 1.25. So here's 1.25. If I'm starting at 0, 1.25 means positive 1. And then another 0.25. Well, I know that 1.5 would be right here. And 0.25 is halfway between that. So 1.25 would be right there. Alright, then we have our negative 1/3, which is negative 3/10 repeating. Okay, so here's 0. It's negative, so I'm moving in the negative direction. And that number in front of the decimal points is 0, so that means it's not going to be between here and here. It's going to be between here and here. And if I'm counting by tenths, here's the 5. 1, 2, 3, 4. It's going to be a little bit more than a regular 0.3. So right there is where I would say negative 1/3 is. Then we have 0.5. That's a nice one. It's halfway between 0 and 1. And last but not least, we have negative 1 and 6/10 repeating. So negative 1 and 6/10 repeating. Here's 0, here's negative 1. Here would be negative 1.5, and negative 1 and 6/10 repeating would be a little bit more than that. So there's my negative 5/3. Now all you have to do is go from left to right and list them in order, and it's all set for you. So the one that's farthest left is the negative 5/3. Next, I see that we have negative 0.5. Next, we have negative 1/3. Next, we have 0.5. And last, we have 1.25. So once you can kind of place them on the number line, then you have the order all set for you. I know, these take a long time. I'm sorry. I won't give you like 100 of them for homework, I promise. Okay, last one here. Again, I see this list of numbers. I need to order them from least to greatest. And maybe some of you, as you're looking at this, think, okay, well, those are positive, so I know those are going to be at the one end, and those are negative, and they're going to be at the other. And we can kind of reason through these as well. This isn't the only way to do this. This is just the way that I know will work for everyone. So what I had said before to do when you're given a number set like this is kind of put them all into the same format. And decimal format is the one I'm going with. If you want to change them all into fractions, have at it. Have a good time. I would just like to go with decimals. I just think it's a little bit easier. So 9/4 as a decimal, that means 9 is being divided by 4. 4 does go into 9. It goes into 9 twice with 1 left over. I need to add a 0, so I'm going to add a decimal point there so I don't change that from 9 to 90. I want it to still be 9. We'll bring down that 0. 4 goes into 10 twice. 4 times 2 is 8. Oh, still have a remainder. I'm going to add another 0. 4 goes into 25 times. And finally, there aren't any remainders because 4 times 5 is 20, so we're good. So 9/4 is 2.25. This one's all set. -5/4. This means 5 is being divided by 4. So 4 goes into 5 once. There's 1 left over, so I'm going to add that decimal point. So I'm still taking the 4 into 5, but I'm getting that 0 that I need. So 4 goes into 10 twice. 4 times 2 is 8. And again, there's my 4 times 5, which is 20. So this would be -1.25. And the rest of them are all set for us. Now, if you kind of understand how this number line is working, and that the greater the digits of the negative, the lower the value, you might be able to just look at this and place these automatically. When I look at this, I see, okay, here's 2 positive values. Here are 3 negative values. And the highest digit count here would be this -1.25. So I know that one's going to be farthest to the left, and then I would have my -1.1, and then -8/10, and then this, and then this. So you don't have to draw a number line if you can reason through it. If you're a visual learner, like so many of us are, then having that little number line will help. So looking at what's my highest positive value, it's 2.25. So I'm going to make my number line go up to 3. And how far to the left I would need to go with these negative values is looking like -1.25. So I'm going to put a -2 here. So then we'd put some values there and try to place these as we go and just kind of estimate. So if you see 2.25, that's positive. Here's 2, here's 3. 2.25 would be a quarter of the way, right? So if I had this separated into fourths, 2.25 would be right here. 0.75 or 0.75, that I don't have one whole amount yet, so that's between 0 and 1. And I think about this in terms of quarters as well, because 25, 50, 75, 100. So I can divide that into 4 sections. If you want to divide it into 10 sections and estimate between, you can. But 0.75 would be right here. Then I have -1.25. So here's -1. I need to keep heading this way. So -1.25 means a quarter of the way between -1 and -2. So there's my -1.25. -0 and 8/10 means it's between 0 and -1. And this time it's tenths, so I'm going to divide this into tenths. Here's the halfway point. This is 0.5. And then I have 6, 7, 8, 9. So -1, and let me put these other ones in here too. I can't help myself. 6, 7, 8 would be right here. The last one I have is -1.1. And I'm going to use a different color just so it doesn't get confused. Here's -1. I'm heading to the left. -1.1 would probably be right about there. So again, we've got all these values set. All we need to do is write what happens from left to right, because that's least to greatest. So the first number we have is -1.25. And actually, it was written originally as -5/4, so I'm going to write it as -5/4. The next one I have is -8/10. The next one I have, oh, I'm sorry, is -1.1. Oh, I wrote in pen too. What am I going to do? All right, let's start this again. I don't want to stop the tape because it was a really long lesson. So start back again. -1.25, which originally in our data set was -5/4. I don't know if you'll have scribbles too. You can probably erase it. Then I have -1.1. Then I have -8/10. Then I have 0.75. And last, in my original data set, it's not 2.25, it's 9/4, so I'm going to write it as it was originally, as 9/4. Piece of cake, right? We'll do more practice tomorrow. See you then.